Hello everyone. Now in this particular video we are going to discuss the previous year question of GATE CSE branch. Okay. Now this question is based on the shortest path. So we need to find out the shortest path using Dijkstra algorithm. Okay. So this particular algorithm, Dijkstra algorithm, is also called as single source path algorithm. Single source shortest path algorithm. Okay. So whenever in the question it is mentioned that Dijkstra algorithm or single source shortest path algorithm, then both are the same thing. Okay. Now consider the directed graph. So this graph we have to consider as shown below. There are multiple shortest paths between S and T. So we have a vertex S and we have this particular vertex T. Which one will be reported by Dijkstra shortest path algorithm? So in this particular graph, we have multiple shortest path and we need to find out which one we will get by using this particular algorithm, right? So assume that in any iteration, the shortest path to vertex V is updated only when a strictly shorter path to V is discovered. So this thing we followed in the case of Dijkstra algorithm only. Whenever we get the shorter path for that particular node, then we will take the path cost for that particular node. Okay. So let's discuss this particular example now, and here we have the options. Now here we have four options: SGT, SBDT, SACDT. If you go through the options, you can observe that SDT. So SDT, so it will cover 7 plus 3, 10 cost. What about SBDT? S, then B, then D, then T. Again 3 plus 4, 7, 7 plus 3, again 10. What about SACDT? So SAC, so 4 plus 1, 5, 5 after that C to D, right? 8, 8 plus 3, 11. So this is 11. And what about SACET? So SACET. So 4 plus 1, 5, 5 plus 1, 6, and 6 plus 4 is 10, right? So out of this four option, I can easily eliminate this particular option because this is not a shortest path. These three are the shortest path A, B, and D. But we need to find out that by applying this particular algorithm, which path we will get. Okay. So let's see out of these three options A, B, D, which one is the correct one? Because option C is anyway, it is not a shortest path. Now what we have discussed in the previous video, let's follow that same process. So first we have a S, that is a source, or we can say a starting node here. From S I can go to A, I can go to D, I can go to B. Okay, so this is this is the source. So I am considering it as 0, and for rest of the other nodes I am considering infinity. Okay, so I am not writing, but you can say it is infinity. Now from S I can go to A, D, and B. Now we'll compare whether 4 is less than infinity. For example, this is infinity. Yes, 4 is less than infinity, so I will update this to 4. Now what about D? So I can go to D now because from S I can go to A, I can go to D, I can go to B. So what cost is required to go to B? Similarly here 3, and for this case 7, right? So S to A 4, S to D 7, and S to B 3. Out of these three path, which one is having minimum cost? Which node is having minimum cost? B, right? So then in the next iteration we will go for a B, not A and D, because 3 is the minimum, right? Now from B, where I can go? I can only go to D or I can go to A. But if I go to A, so here already it is a 0. So it will, if I go to 0, so it will take 3. So whether 3 is less than 0? No, that is not true. So we are not going to update this. Now from B, I can go to D. So 3 plus 4 is 7. So 7 is less than 7. No, that is not true. But anyway, this is a 7. So we'll keep this 7 as it is. Okay. Now we are already explored B. Okay. And the value of D node is 7 only. We can reach this particular node at the cost of 7. Now out of this thing A and D, so A is having 4 and D is having 7, right? Which one is minimum? 4 is minimum. Now let's explore 4 now. Now I can go to C only, right? There is only one arrow from the 4. So what it will require? 4 plus 1, 5. So I am at this particular node now. C, 5. So I can reach the node C at the cost of 5. I can reach the node D at the cost of 7. Now which one is minimum from this to C? Then I will go to C like this. From C I can go to E also. I can go to D also. Now let's see. So what is the cost required for going to E? So 5 plus 1, that is 6. Okay, so this is 6. What is the cost required for going to D? 5 plus 3, that is 8. Whether 8 is less than 7? No, that is not true. So we are not going to update the value of 7. So we will keep as it is. Right? So from C I can only go to E. So this is S, this is A, this is C, and this is E, right? So this is 4, 1, 1. Now from E where I can go? I can go to G and I can go to T directly. If I go to G, at what cost I can go? 8. But if I go to T, what will be the cost? 10. So from E I can go to T with the cost of 4. So total cost is 10. Now if you observe, by using this particular path, I reached the my node T by using Dijkstra algorithm. Okay, so SACET is the shortest path we will get by using this particular algorithm. So option D is correct here. Okay, so this type of question you can expect in the GATE exam. Either they will give you this particular graph or they can give the adjacency matrix for a particular graph. In the previous question, in the previous year question of GATE CSE branch, this was the one of the question, and in one more question they have given the adjacency matrix for this particular graph. So you should know how to convert this graph into adjacency matrix and how to convert the adjacency matrix into this particular graph. Okay, so I hope this thing is clear and how we got this answer 10 SACET. Okay, so this is the shortest path that we will get from this particular algorithm. This is also shortest, this is also shortest. If we continue to go through the iteration, we will get these two path also. But what is the first path we got? SACET. So that's why this particular option is correct, SACET, at the cost of 10. Okay, so I hope you understand this particular concept and how we got the answer. So that's it from this particular video. Thank you.